Okay, let's proceed to the next talk. It's titled Determining Video Complexity to Optimize Video Quality Assessment. It will be given by Jan Zroo from Sky UK.
All right then. Well, it's a pleasure to be here. Most people know me as an encoder man, who's worked for vendors, sort of Harmonic, Tandberg, InVivio. I changed my spots and I now work for a broadcaster, Sky. I'm in charge of emerging technology, and I'm a fraud here. It should have been my member of staff who was presenting this, Ivan, who was co-author of the paper. So you've got Ivan's manager rather than the real technical man who should have been presenting this. I've really enjoyed all of the presentations, and I mean, it's a real treat to actually come to this kind of presentation where people are doing a deep dive on video quality. I loved all of the comments about pre-processing, the temporal filters and so forth, and they're all very relevant to the kind of presentation that I'm going to give to you now. Just in terms of an introduction, what I'm talking about here is really complexity measurement and the importance for maintaining video quality. One of the responsibilities I have at Sky is for measuring subjective and objective performance to maintain the quality across all of our platforms. Specifically, this was about methods of actually assessing complexity over a range of different platforms. So what we'll be looking at is we'll be looking at the incumbent systems, the ITU 910 spec and temporal index and spatial index. We'll look at bitrate as a measurement of complexity, a little bit on encoding modes, a little bit on constant rate factor and complexity profile variability. One of the things that I think has continually cropped up is this issue about input format, whether you use mezzanine formats or whether you use baseband SDI. And then I'll wrap it up with a couple of user cases, one UHD, one HD, and talking a little bit about some of the work that we do with StatMux. And last, I'll hopefully prove the hypothesis of the paper that basically you can use CQ and CRF as measures of complexity. So just as an introduction, and I would actually say that this is only a subset of the paper, that if you want to go into more detail, do have a look at the paper. I'm quite clear about the kind of content that Ivan and I used to perform this test. It's all content that you'd be very, very familiar with. Confetti, crowd run, a lot of the standard EBU sequences. We've tried to use sequences that are easily repeatable. So if you actually look at the paper, we sort of build up the case for the various aspects that we're trying to prove. But basically, as an introduction, we're trying to understand content complexity and how it's used to optimize encoder assets. We'd actually say that we can actually use content quality and constant rate factors, that they're very good candidates for complexity, and I'll explain why in a minute. One of the things that we're constantly looking at is the input format that we're looking to use. There's a great deal of difference between baseband SDI and some of the mezzanine formats and the preconditioning that codec stage provides up front of the encoder. And then lastly, we will look at statistical multiplex systems and how they rely on complexity as a measure. And I know that some of the encoder vendors have done some very good explanations of StatMux systems and a bit of a deeper dive about how they use complexity measure on their systems. So, I mean, first of all, anyone who's familiar with assessing encoder complexity will be familiar with P190. It has a temporal and a spatial index. I'd say sometimes subjectively that's acceptable to use, but really it's inadequate simply because it can be easily fooled. And one of those aspects is temporal index is good for determining temporal entropy rather than complexity. And the spatial index can be fooled particularly by high frequency or repetitive patterns. To give you an idea there, if you were actually looking at a railing or a grating or wall or something that's quite easily encoded, that can actually be confused with quite high complexity content. So both SI and TI are not particularly good measures for complexity. And another thing is this balance of representative content that you're actually using for your tests. In this particular scenario, you want really sort of very high, moderate, and easy content. But you do actually need to understand that the majority of the content is actually of quite low complexity. And particularly for StatMux systems and the way StatMux actually works, where you're robbing Peter to pay Paul, you're looking for the low complexity scenes that you can harvest bit rate from to give to the slightly harder content to encode. So that's a very important consideration. Now, in terms of complexity, what we were using was we were actually using the FFmpeg X264 library, medium preset, YUV420p. We were using both content quality and constant rate factor parameters. I'm just making sure I'm covering all of the points here. What I actually do in terms of the content that we've got, you'll see in the graphic up there, it's very easy to see the various sequences that we've got. We've got park run, ducks, and so forth. And what you actually see is that this is actually a UHD sequence with mid to high complexity. The graph shows average bit rate versus frame number. And basically what we were trying to do is basically prove that either CQ or CRF could be used for estimating complexity. Does it matter which one of those parameters are chosen? And also, does encoder complexity depend upon input format? The test content, as you see, it's probably too small, actually, as it's shown there. But if you look at the paper, we were using live football, a fairly well-known EBU sequence of confetti, celebration golf, and quite a few of the common test sequences that are often used for encoder evaluation. So, sorry about this. So if we were actually looking at the encoder mode, what about constant content quality or constant rate factor for determining bit rate profile? The tests that we've doing have shown that for every CQ value, there's a corresponding CRF, equating to a similar bit rate profile in either scenario. Some of the graphs that I'll show later on. It basically concludes that either factor can be used to estimate content complexity and correctly tracking the encoder bit rate according to that complexity. If you look at this particular complexity profile variability with, first of all, constant rate factor level. The above figure is trying to determine whether the content complexity represented as bit rate profile varies with the CQ or CRF parameter used to generate the bit rate profile. Now, what we were doing in this particular analysis is looking at the two extreme values of constant rate factor, one at 10 and one at 20, normalized in a range from 0 to 1, where 1 equates to the maximum bit rate in the stream. So when the high, quality level is high CRF, the encoder will try and preserve noise and any fine detail. And I think that's particularly important when you're considering the signal sources, that not only will you be preserving high-frequency inputs, but there is the potential actually of encoding noise, and we'll talk more about that in a minute. But during the sequence, what you see is that there are lower quality sections of the content where the CRF is 23, where the clip is relatively simple to encode, which require much less bits than the previous complex sequence. In the graph that you're seeing, and I would recommend you looking at the paper, the CRF of 10 is in gray and the CRF of 23 is in teal. What I've done is broken down the various frames, just to give you an idea. In frames 6,000 to 8,000, it's a penalty shot with a static camera that's, when encoded with CRF10, are of a similar complexity to some of the later scenes that you're seeing. And what we're trying to do is basically show the constant rate vector level does actually, sort of equate fairly well with the content quality measure that we were also testing. This graph needs a little bit of an explanation. I mean, what we're actually showing, if we look at the example here, is that we've got the constant rate factor 10 is shown in gray, and the constant rate factor 23 is shown in the tealy blue color. And what we're trying to do is show various different scenarios. The capped VBR is shown in orange, and the CBR is shown in green at approximately 18 megabits per second. Again, we're using complex parts of content, namely, sort of confetti, crowd run, ducks, and park joy, which are sort of fairly familiar sequences. What I would say is, if you note that the content-aware encoder has a max bit rate set at about 40 megabits per second, and what you'll see is that the content-aware encoder roughly equates to sort of what you're seeing with the CBR encoder at about 18 megabits. I would recommend looking at the paper, but the main point that we're trying to do is to show that the various ranges that we've got, where there's high complexity or low complexity, is to demonstrate the fact that constant rate factor level is a good measure of complexity. What I'll do is, so that I don't run over time, we also sort of talk quite a lot about the input format and the differences between sort of a baseband SDI input and the impact that has versus mezzanine. And I think that in a nutshell, what we're actually getting at here is that the signal preconditioning especially before distribution encoders, is particularly important. And you get a very, very different characteristic from using uncompressed SDI versus mezzanine encoding before the distribution encoder. And I mean, what you do is we provide a very good example of this, where the SDI input is actually shown in gold here, and the IP mezzanine is shown in red. And it's clear that the SDI encoded content used far more bits to encode the sequence and was reaching the cap of 40 megabits more often. With the last minute and a half, because I'm strict on time about finishing, what I did is I do talk about some of the StatMux scenarios that we've got. And basically, selection of content is everything. You've got to have a good mix of content. I think in the example for UHD StatMux planning, I actually demonstrate the use of CRF10 and CRF23. You actually sort of look across a range of content. So in this particular example, we've got football, we've got news, we've got some Olympics coverage. And it's very important that you actually carefully look at what the complexity of the content that you're actually using and what the benefit savings are for StatMux systems. One thing that I would say is that in this particular scenario, we're tending to only use low numbers of channels for UHD StatMux, but the more channels you have, the greater saving you've got, because the more potential saving there are across the various content types. So 2 channels, you get a moderate saving. You know, up to about 8 channels, you get a very, very good saving. And so we also have applied this to some of the work that we're doing for HD statistical multiplexing. One of the key things, activities at the moment, is to actually restrict transponder space that we're using to either get more channels in or reduce the overall satellite cost. And some of the work that we're doing is particularly associated with HD StatMux systems. So I'm right out of time, but I'll go through my conclusions. We believe that content complexity can be accurately tracked using the bit rate of constant quality encoding. It's important to use representative test sequence and not just complex content. Import format does have a significant impact on encoder quality, and the approach outline can be extended to statistical multiplex systems. So that's the end of the presentation. Just about got in there. Any questions?
We have time just for one short question, so please, yeah.
Yeah, I'm always confused by the term CIF. Being from the coding, it's not constant rate at all. So
Yeah.
Can we please get, no, but don't get me started on that word. I just have a question about the bit rate per frame. How is that calculated? Is that a windowed approach? How long
It is.
The window is like the GOP, what's the window size?
Well, it's aggregated over the GOP usually, yeah.
Okay.
Yeah.
So that corresponds then to the buffer, and it's...
Yes,
okay.
that's right, yeah.
Thank you.
Excellent. Thank you very much. It was a very interesting talk.